Hey boys and girls, and happy Friday. The very last Friday in February. Can't believe it's almost March and we have quite a few things to do today. We are going to look at our calendar collector to see how many degrees we've collected this whole month, to see if we can make it past that 3/4 mark. We're also going to look at our calendar grid marker, or the markers for the rest of the month, and talk a little bit about angles. Lastly, we have a problem string. So if our video runs a little long today, I'll apologize in advance. But some of the things that we're going to be doing are important to wrap up all the things we've done this month. So let's get started with our calendar collector. So far we have 257 degrees, and we know 3/4 of the way is 270 degrees. And look, we made it past because we just spun 45 degrees. So if we had 257 and we add 45 to it, what should we get? $302 degrees. So we made it way past, not way past, but a good bit past where I was hoping that we would get to at least 3/4 of a full rotation. So let me change my color. It will be, let's do blue. And I'm adding 45 degrees until I get to 302 degrees. Look how close we are to a full rotation. We're very close. So that's how many degrees we have collected this month. And this month we've been focused strictly on angles. And we talked about how a full rotation is 360 degrees. And we've collected angles. So we have about maybe a sixth left to go for us to complete our whole rotation. But the month's over, so that's as far as we get. Since it is February 26th, let's go ahead and look at our calendar marker for today. So we have another quadrilateral. And then this weekend we would have the line segment and then 2 line segments. So it does follow the pattern that we have just established. I want to say one big idea this month that maybe I haven't already shared with you is when we're talking about angles, we have 90-degree angles, we have straight angles, we have acute angles, we have obtuse angles, we have reflex angles, we have straight angles, all the angles. But what about when you have angles within a shape? Well, I'm going to tell you that the angles inside of a triangle always add up to 180 degrees. 180 degrees. And so we're going to solve a few problems regarding angles in just a moment, but I just want you to know that. When it comes to a quadrilateral, though, the angles in a quadrilateral are always going to add up to a full rotation around a circle. Do you remember how many degrees it takes for a full rotation? 360 degrees. Say it with me. 360 degrees. So a triangle, all 3 angles add up to 180 degrees. And in a quadrilateral, all 4 angles add up to 360 degrees. So with that in mind, let's look at this page. We have some mystery angles here we're going to try to solve for. And if I'm going quickly, I apologize, but I want you to buckle your seatbelts and take the ride with me, because here we go. What is the measure of the mystery angle? What kind of angle would this whole thing be if I were talking about this right here? We've seen that angle before. It is a straight angle. And what do we know about a straight angle? It measures 180 degrees. So if I know that of that 180 degrees, I already have 30 degrees, how can I figure out the remaining size of the angle? Well, I'm going to subtract 30 degrees. If I subtract 30 degrees, what am I going to get? I'm going to get 150 degrees. Another clue is that I can clearly see it's an obtuse angle because it's bigger than 90 degrees. So if for some reason you did some math and your answer came up to be less than 90 degrees, then we know that that couldn't be right. And we could always check our work by adding 150 plus 30 degrees, and that would give us 180. Moving right along to number 2. What's the measure of this mystery angle? Do you remember how many degrees a triangle adds up to? 180 degrees. So that means I need 130 plus 30 plus something is going to equal 180. What is 130 plus 30? Good. 160. So how much more would I need to add to give me 180? Let's count by tens if you need to. Awesome. Our unknown in this case is 20 degrees. So the angle is 20 degrees. All right, number 3. Now we have a mystery angle inside of a quadrilateral. Do you remember what the angles add up to inside of a quadrilateral? 360 degrees, like a full rotation around the circle. So in order to figure this out, I'm going to write a fancy equation. I'm going to do 360 minus, and I'm going to use some parentheses because I think parentheses are fun. And we've talked about parentheses this month. 135 plus 35 plus 90 equals our unknown. So let's solve for within the parentheses first, which is what we're supposed to do. What is 135 plus 35? Good, that's 170. Now I need to add 90 to that. Right, it's 260. So that's an easy problem. 360 minus 260 would give us what? 100 degrees. Our unknown angle is 100. Here's the other thing I'm going to tell you. I'm going to zoom in really quick. I can see if I were to take a straight edge, that this piece would have been 90 degrees, and it's only slightly bigger than 90 degrees. And that makes sense with the answer that I got. So we're actually going to stop there for this page because I just wanted you to have that information, that triangle angles add up to 180 degrees, and then quadrilaterals add up to 360 degrees, and we can use operations such as addition or subtraction to solve for an unknown angle. And now to our main event, the problem string. I'm going to warn you, the problem string is a lot like what we did the other day when we did a problem string, where we were adding and I think we subtracted some fractions. When we did that, we realized that we had to first put the fractions in a form that would allow us to combine them, which means having a common denominator. Now, I'm going to clue you in on something here for South Carolina standards in 4th grade. It says you guys should know how to add and subtract mixed numbers with like denominators. So if you are understanding how to add and subtract these fractions that don't have like denominators, you're in good shape because you will be doing that a good bit in 5th grade. However, the other standard says that you need to compare fractions by creating common denominators. So you should already know how to make equivalent fractions so that fractions have the same denominator. But I'm going to give you another little insight. The fractions that we used the other day lended themselves really, really well to money because they ended in denominators like fourths, fifths, halves, and we could easily think about money when we're talking about adding and subtracting those fractions. The fractions that we're going to do today, however, don't really go well with money because we're going to be dealing with thirds and sixths and maybe even twelfths. So I'm going to say we can think about a clock, time. So as we are solving these problems, and yes, this may be challenging for some of you, but that's okay. It's okay because you're going to do more work with it in 5th grade. So just try your best. Make the effort to think about it and make sense of the things that I'm saying and follow along with me. That's really important. We are going to think about these fractions in terms of time before we add or subtract them. Okay, so let's look at the very first one. And it says, let's scoot this over some. Okay, 1/2 plus 1/3. I help my daughter for half of an hour, then help my son for a third of an hour. How much time did we spend on their homework? So putting in context, I'm going to go to my handy dandy fractions app. And since I know that talking about time, or I'm going to use time as a benchmark, I am going to create use a circle, and I'm adding 1/2 plus 1/2 plus 1/3, just to remind you of the problem. And we're only going to do a few of these because, like I said, this is not necessarily a specific standard to 4th grade where you're adding fractions with unlike denominators. But a standard in 4th grade says you can create common denominators in order to compare fractions. So we're going to combine that with adding and subtracting. And it should be easy because we're using a benchmark of time. And you guys know how to tell time, right? So let's think of half in terms of an hour. How many minutes is 1/2 of an hour? Good. So 1/2, 1/2 is the same thing as saying 30 minutes. And for some reason I can't write words with this app, so you'll kind of have to imagine that I put the word, or maybe I can use my pen tool, put minutes after it. So 1/2 is 30 minutes, and here's my 1/2 so far. I want to add a third to that. Well, how many minutes is 1/3 of an hour? That means I'm taking 60 minutes and I'm dividing it into 3 equal groups. 60 divided by 3 would give me 20 minutes. And that makes sense because we know that 1/3 is less than 1/2. So if I take 30 minutes and I'm adding 20 minutes to it, which may look a little bit like, and I'm going to try my best here to be as accurate as possible, may look a little bit like that. And here's my 1/3. How many minutes am I getting in total? I'm doing 1/2 plus 1/3, which is the same thing as me saying 30 minutes plus 20 minutes, and that's going to give me 50 minutes. I'm going to write 50, and that's how many minutes I got. Maybe I should do 30 plus 20 equals 50 minutes. But we need to put this in terms of an hour. So 50 minutes, how can I write 50 minutes as a fraction? How many total minutes are in an hour? There's 60 minutes in an hour, and I'm only talking about 50 of those minutes. So 50 1/60th size, because when you talk about a clock, you go 1/60th 60 times in order to complete a whole minute if you're talking about seconds, or a whole hour if you're talking about minutes. So I could say 50 60ths. I could also reduce this because I know 1/2 is the same thing as saying 3/6, and that is me creating common denominators. And 1/3 is the same thing as saying 2/6. And so therefore 3/6 plus 2/6 equals 5/6. Now hopefully I explained that in a way that makes sense to you. If not, we're going to do another one, and maybe it'll start making more sense as we continue working. Let's look at this one. I now have 1/3 plus 1/6. I help my daughter for 1/3 of an hour and then help my son for 1/6 of an hour. How much time did I spend with them on homework? So let's look back, and I'm actually going to go to my Whiteboard app for this one. And here I am on the Whiteboard app, and I know I'm adding 1/3 plus 1/6. I am going to draw a circle since I'm on a Whiteboard app and I don't have a pre-made circle. I'm going to do it as best as I possibly can. Okay, so we know what about time. This would be 12, this would be 6, this would be 3, and this would be 9. And that's me splitting it into fourths, but I want to split it into sixths. Since that's my larger denominator, I want that many pieces to start with. So if I split 60 minutes into 6 equal groups, I'm going to get how many minutes per group? 10 minutes. So I am going to separate my clock like this. And I know, guys, that it's not perfect, but just bear with me. So I have sixths here. I am trying to add 1/6, which is here. Here's my 1/6. And I need to add a third to it. The question is, how many thirds are equivalent to sixths? We need to make an equivalent fraction here. Here's 1/3 equals how many sixths? Well, if you're having trouble, remember I talked about 1/3. I said before, or maybe I didn't. I did. 1/3 is equal to 20 minutes. And 1/6, I just said, is 10 minutes. So if you think in terms of minutes, maybe that'll make it easier. So 20 minutes plus 10 minutes would give you what? Right, 30 minutes. And we know 30 minutes is half of an hour. I want to write my 30 minutes as a fraction. How many minutes are total in an hour? There are 60 minutes in an hour, so 30/60ths would be my fraction, because I've only gone 30 minutes of them. When I'm thinking about equivalent fractions, I know 1/3 is the same thing as saying 2/6. How do I know that? Well, if 1/6 is 10 minutes, 1/3 is 20 minutes, then I'm just adding another 2/6 to that. You see that? So essentially, how much of a whole clock do I end up with? How many sixths? Yeah, 3/6. And 3/6, we all know, or hopefully we know, is equivalent to 1/2. So we have 1/2 of an hour. So what we've done is when we're adding fractions, and some of you may get questions like this on your math test, which is why I'm glad we're introducing it. And so I really want you to try to understand what's happening. But you're going to do a whole lot more work with this in 5th grade if it's like going way over your head. Just stick with me for a few more minutes, okay? Before we can add fractions that don't have the same denominator, we have to turn it into common, or we have to make it so that we can combine them, which means we have common terms. And that's what we did here. We made it minutes and minutes. And then, in order for us to think about it as a fraction, we had to think about how many minutes are in an hour. Let's do maybe one more, and then we'll call it time for the day, and that'll wrap up our February number corner. So, last one. No context. Now we're just adding a sixth plus 2/3. 1/6 plus 2/3. I'm just going to separate my page here. Okay, and I'm adding 1/6 plus 2/3. All right, let's create some common terms. Let's make it so we can combine them. 1/6 we have up here is 10 minutes. 1/3 is 20 minutes. So then 2/3 would be 2 times 1/3, or essentially 2 times 20 minutes, which is how many minutes? 40 minutes. So right now I am at 10 minutes plus 2 times 20 minutes, which is the same thing as saying 10 plus 40. Y'all agree? All right. Well, what is 10 plus 40? 50. And that's 50 minutes. My unit here is minutes this whole time. And so I'm having 50 minutes. But the question is asking me 1/6 plus 2/3. So I can't just write 50 minutes because that wouldn't make any sense. I need to write it in terms of a fraction. So let's think about minutes related to an hour. How many minutes are in an hour? 60 minutes. So then my fraction would be 50/60ths of an hour. And that could be my answer. I could leave it there. But I could also simplify it. Because 50/60ths of an hour means I have 5 1/6 size pieces. Because a 1/6 is 10 minutes. So if I have 50 minutes, I have 10, 20, 30, 40, 50. That means essentially I have shaded in, or I have gone, or time has elapsed a total of 50 minutes. And so I could write this fraction as 50/60ths, or a simplified version would be 5/6 of an hour. And that's equivalent. It means the same thing. I can go on and on, but I'm not. We're going to stop there unless you want to challenge yourself to do 3/12 plus 1/6. And maybe if you do that, you can send it to your teacher. I don't know, maybe she's or he will give you some extra credit. Because you have to think, you have to first create common terms. You have to make it so you can combine them. And for today, we're thinking about time. So you would have to think about, well, what's 1/12 of an hour? That means 60 minutes divided into 12 equal groups. And then figure out what a 1/6 is of an hour, which we know, in order to solve this problem. I'm curious to see if you could do it. And if you can't, it's okay. Maybe you should try, because what harm would that do? But I'm going to stop there. We've way past our time for today. Thank you for sticking with me. I know this video may have been fairly quick, but we did a lot of work today. We did a lot of work this month. We talked about angles. We didn't necessarily measure angles, but we estimated the size of an angle using benchmarks. We added fractions, we subtracted fractions, we solved problems, we drew different types of triangles and quadrilaterals, all kinds of things this month. I can't wait to see what next month is all about. You guys enjoy your Friday. I will see you next week. Bye-bye.